In this lecture, we're going to learn about the final specifier used in inheritance hierarchies. This is going to allow you to do one of two things. You will either be able to restrict how you override methods in derived classes, or you can restrict how you can derive from base classes. I know this is in the air, but we're going to look at a few examples to really drive this home. Suppose we have an inheritance hierarchy like we see here. The top class is animal. We can derive from this and have feline. We can have bird as a derived class. Feline can be inherited to have dog and cat. And you can derive from cat, for example, to have wild cat and bulldog from dog. You can do all these things here, and this is inheritance hierarchy we're going to be using to learn about these things. Now, here is a possible implementation for the dog class, which is going to be inheriting from feline publicly as we see here. But take a look at the run method we are setting up in dog. We are appending a final specifier, and what this is going to mean is that no downstream inheriting class will be able to override the run method further. This is what we can achieve. So if we don't want our derived classes to override our virtual method, we can mark that method as final in our class. And we are basically saying, I am going to put in my implementation, but I don't want any deriving downstream class to override this method further. If they do that, they are going to get a compiler error. And this is something we can achieve using the final specifier in our inheritance hierarchy. Again, in this case, we are using this to restrict how people can override our own virtual method in downstream classes. Or I shouldn't really say our own method because it may be coming from upstream, but you are restricting people from overriding that method further in downstream classes here. Okay, so this is the first use we have for the final specifier. But we can also restrict people from inheriting altogether. So here we have a simple example to drive this home. We have our cat class. It is going to be inheriting from feline, but we are marking our cat class as final. And what this is going to mean, if anybody tries to inherit or derive from cat in any way, they are going to get a compiler error, and this is what we can achieve with the final specifier. Again, there are two things. You can restrict how people override your virtual methods. If you want to restrict that from the current class, you can mark your virtual method as final. You can also restrict how people inherit altogether from your class, and if you want that behavior, you can mark your class as final using the syntax we just saw in the slides here. Okay, now that you know these things, let's look at a few things that may be interesting. For example, here is a simple fact that you can create a class right away and mark it as final. And when you do this, nobody will be able to ever inherit from this class in your program. And if we do this, we will get a compiler error, for example. This is one thing I find interesting, and I really wanted you to know this. Another thing is that it is possible to introduce useless virtual methods in your inheritance hierarchy. For example, if our cat class is marked as final, what this means is that nobody will ever be able to inherit from this class. But we are going further and setting up a virtual method which is meant to be inherited or overridden in downstream classes. But how do we get a downstream class if we can't inherit from the cat class which is marked final? So we have conflicting ideas here. On one hand, we are saying we can never inherit from this cat class. But on the other hand, we are setting up a method that is meant to be used or specialized in derived classes. So this is something that is interesting. This code is going to compile, and I think maybe in future standards of C++, they are going to fix this problem and maybe give you a compiler error if you try to do something like this. But at this point, you're not going to get a compiler error. This is just going to be valid C++ syntax. Even if this is really weird, we have conflicting ideas here. Okay, one thing you should know though is that we can override in a final class. And this is going to make sense because, for example, the run method is coming from the feline class. And here we are just specializing that, so we are marking that as an override here, even if this is a final class. So be careful, this is valid C++ syntax, this is going to work just fine. Another thing you can do, which is pretty useless in your C++ program, is to introduce a virtual method and mark it as final right away. So again, this is really weird. We have two ideas that are conflicting. The virtual keyword means that we want this to be specialized in the downstream classes. But again, we are saying this method is final. So no downstream class will override this. If they try to do that, they are going to get a compiler error. So this is again a bunch of conflicting ideas. C++ is going to allow this syntax. This is not going to give you a compiler error, but this is weird and you need to be aware of this. Okay, now that you know these ideas, we're going to head over to Visual Studio Code and play with the final specifier in our inheritance hierarchy. We will be setting up this kind of inheritance hierarchy, and we will set up a bunch of virtual methods and mark them as final. I think we will do that in the Dog class, and we will mark a bunch of classes as final and see that if we inherit from them, we're going to get a bunch of compiler errors. So let's do this. Here we are in our working folder. The current project is final. And we are going to bring in our template files pretty quick. We're going to use this as our starting point. We're going to put that in place. And I am going to put in a bunch of classes I have lying around on my system because I don't want to set up these classes. That would be a waste of your time. Just know that we are trying to set up this kind of inheritance hierarchy. Animal is going to be our top dog, or animal is going to be our top class, and we will be inheriting from this, creating an inheritance hierarchy we can play with in our code here. Okay, so we are going to open this up in Visual Studio Code. So let's do that by dragging and dropping here. This is going to give us all these crazy classes we have. The top class is going to be animal, and it is going to be defining the features any kind of animal we support in our C++ program is going to have. For example, any kind of animal will need to breathe, and we will set up this virtual method here. And we will be inheriting from this animal class to create a feline class and a bird class. This is something we did in a few previous lectures, and we are just reusing this inheritance hierarchy here. Let's look at the feline class. The feline class is going to set up a virtual method which is called run, and the method is going to be overridden in the dog. For example, we can override the run method, but notice that we are marking that as final. Okay, so look at this. The method is final, and what this means is that no downstream classes inheriting from dog will ever be able to specialize or override this method further. If they try to do that, they will get a compiler error. Notice that this may be our method, or it may be a method coming from upstream classes. In this case, the run method was introduced at the feline level. You see it was introduced here, and dog happens to be overriding this method here. That's why we have the override keyword, but at the same time, we are going to mark it as final and prohibit or prevent downstream classes from overriding this method further. If we look at our bulldog class, we're going to find the class to inherit from dog. We have our run method here. It is commented out at this moment. I just want you to see that our code is just going to compile. If we compile it now, let's do this. We're going to pass this through GCC. Okay, you see the bold is good, and we have generated our binary, which is really not doing anything because our main function is just some dummy code we have here to make sure it works with C++20. But what I want you to see is that if you go in bulldog, let's go in our bulldog class and uncomment this class here, or this virtual method, we're going to see that we're going to get a compiler error. We have a squiggly line, meaning that we did something wrong. And let's look at the problems tab from Visual Studio Code here. Cannot override final function dog run. This is a final method from the dog class. If we try to override it further, we will get a compiler error. This is something we can achieve by marking our virtual method as final, as we are doing here. Now, if we try to build this program, we're going to get a compiler error. Let's pass this through GCC and let you see this. Okay, you see we get a compiler error, and the error is that we are overriding. Let's go up and see the error here. Error, and on line 12 in bulldog H, we see that we are overriding a final method. Virtual void bulldog is a final function, and we are overriding this, and this is going to give us a compiler error. This is the behavior we get. So the message here is that you can go in your inheritance hierarchy at any level and mark a virtual method as final and prevent downstream classes from specializing or overriding that method further. And if they do that, they will get a compiler error. This is something we can achieve in our C++ program. Another thing you can do with the final specifier is that you can prevent people from inheriting from your class altogether. Let's go to our cat class. I think that's the example that sets that up. We have a cat class. It is going to be inheriting from feline, but the class is marked as final. Now, what this is going to do, it's going to throw a compiler error anytime somebody tries to derive or inherit from this class here. So if somebody tries to inherit from cat, as we are doing here, create a wild cat from a cat, we are going to get a compiler error because we can't inherit from cat altogether. It is a final class at this moment. Okay, so let's look at our wildcat class. It is going to try and derive from cat. We can do something like this. We can remove our comments here. And if we try to do this, we will get a compiler error. Let's look at the CPP file and see what we have. It has nothing special. But if we try to do that and inherit from cat, we will get a compiler error because the cat class is final and you cannot derive from it. If you do that, you will get a compiler error because the cat class is final. This is what I want you to see here. Let's try and build our program again. We're going to pass this through GCC and we will see our compiler error. Okay, the build is finished with errors. If we go up, we will see that we cannot derive from a final base class. If we do that, we will get a compiler error. And this is what I want you to see here. Okay, now that we know this, we're going to take this back and take out the compiler error here because we want our code to compile. We're going to make sure it is compiling fine. Okay, now the code is compiling because we are no longer trying to inherit from cat. And I want you to now see a few interesting facts about the final specifier when it works together with virtual functions. Let's go to the main CPP file and show you the first fact. And that's that you can create a class right away and mark that as final as you create it, as we do here. If you do that, this class is going to not be inheritable. And if you try to inherit from it, you will get a compiler error. Let's take out everything we have here and just say hello in our main function. This is going to do just to have something. This is going to give us a compiler error because we can't inherit from a final class. Let's build and show you the compiler error. This is going to go through GCC and the build is going to finish with errors. And we have our message here. And we don't have the error we expected because we forgot to put our closing semicolon on our class definition here. But we can build again and get our error. Okay, the build is finished with errors. And the error is going to be that we cannot derive from a final class. This is what we expect here. Let's comment this out because I just wanted you to see this fact. Another interesting thing C++ allows you to do is to set up a new virtual method in a final class. Let's first build and make sure the compiler error here goes away. And I am going to show you that. Okay, the build is good. Let's go back in our final class, which is the cat class. If I remember correctly, this is a final class. We can't derive from this class, but we can set up a virtual method. For example, the virtual method here called meow is useless. Why is it useless? It is a virtual, and marking it virtual means that you at least want people inheriting from this class to inherit it and use it. Or even better, you want them to have the ability to specialize or override this method and make it do more specialized things. But you can't really do that because you can't derive from this class altogether. So this is something that C++ allows us to do, but this is a useless method which will never be used in any way. So this is something I want you to be aware of. But this is going to compile. Again, let's pass this through GCC. You're going to see that this is going to compile and work. Even if this method is really useless, I want you to be aware of this. Okay, so the build is good here. Okay, so this is our interesting fact number 2. Okay, even if this method is useless, it is possible to specialize a method coming from upstream classes from your final class. For example, in Feline, we have a method called run, which was introduced there, I think. We can override this method in our final class, which is the cat class here. So this method is going to be useless because it will be specializing what we get from our upstream class. This is going to work. Okay, so since we are looking at a few useless things you can do with final combined with the virtual mechanisms in C++, I want you to see that it is possible to set up a virtual method and mark it as final in the same declaration. And we're going to go to the bird class and really show you that. For example, we have a virtual method which is called fly, but this is marked final the moment we declare it. And this is going to be contradicting. For example, the virtual keyword means that people downstream will be able to specialize this or inherit this. But at the same time, we are marking this guy as final. So we are saying nobody downstream will be able to override this method. If they do that, they will get a compiler error. Now, which one is going to win, virtual or final? Final is going to win because if you try to override this method in downstream classes, you will get a compiler error. Let's go down and look at one bird we might have in our program. For example, we might have a pigeon. Let's grab this method and try to override it. You're going to see that we get a compiler error. We can go in pigeon and put in the fly method. And for example, we're going to say pigeon fly here. And we're going to say override. We are trying to override this method, but we're going to get a compiler error. You see we have a squiggly line because this is a final method. And we are trying to override this in a downstream class. And this class is a downstream class from bird. And in bird, we marked this method as final. So this is not going to work. Even if this is virtual, you want to be able to really use the virtual mechanism because this is final. If we try to inherit from this, if we try to override this like we are doing in pigeon here, we will get a compiler error. Let's try and build our program and we will see that we get our trusty compiler error. The build is going to finish with errors. And if we go up, we're going to find our error. We're going to say virtual function fly overriding final function. We are overriding a final virtual method. And this is going to give us a compiler error. We can't do this. This is something you can't do in your C++ program. So this is really confusing because in bird, the virtual keyword suggests that you can really specialize this in downstream class, but this is contradicting, and C++ allows you to do this. You need to be aware of this. Again, if we don't override this and leave this in, the code is going to compile, but in my opinion, this is really confusing and you need to be aware of this. That's the whole point of this lecture here. Let's make sure the code is building, and this is really all I had to share in this lecture. Introducing the final keyword to you. You can use it to restrict how people override your virtual function, or you can use it to restrict people from inheriting from your class altogether, and use these things if they make sense for whatever application you are designing with C++. We are going to stop here in this lecture. In the next one, I am going to show you a secret you probably didn't know. So go ahead and finish up here and meet me there.